Now, where did we stop last Thursday? We stopped on Thursday on putting a block on an inclined plane. So we want to, and we know the slope of the inclined plane, and we want to determine whether it is no motion impending, or we have motion, which is sliding down, of course, or there is motion. Of course, this is downward. Now on note, let's talk about motion impending first. On motion impending, the friction force is at its maximum. So friction force is maximum, so maximum friction force is equal to mu s times n. Now mu s times n, and of course our free body diagram has n the support force from the surface, the reaction from the surface. We have friction force F, which is equal to mu s times n. So for these two forces adding together, and it should be equal to minus W, because summation F equal to 0, right? There is no motion, so summation F equal to 0. So n times F, sorry, this should be n. This should be n plus F is equal to minus W. And in this case, we can know that theta should be equal to arctangent of mu s times n divided by n. So we say that the angle theta is equal to arctangent of mu s. We determine this is we will say this is angle of friction. So what? So you can write it down here. What happens if this theta is greater than phi s? Of course, we still have n, and we still have f. We have n and we have f, but let's say here, this is W, and this is n. But we have f looks like this. And for n plus f is equal to this one. N plus f plus W is not equal to 0. Right? So it has a small summation f here, so it is going downward. If it goes downwards, it means summation f is not equal to 0. So it is in this case that reaction force N and friction F, that they add together, it is going in this direction. Now, I think you can imagine what's happening here. You know the word imagine, right? 想象哈。 So, and so how about the mathematics? Let's take a look. When there is motion, what is the relationship between F and N? If there is motion, what's the relationship between F and N? If there is motion. Let's take a look of 1, 2, 3 pages before. This is this one. Okay. Friction is equal to mu k times the reaction force if there is motion. So here we have mu k times n. And let me make a small change here. So F is here, and this one is theta. This is theta, and we can see that because this is right angle here. So this angle phi k is smaller than phi k is the angle formed by these two forces. So what is phi k? Phi k is equal to arctangent mu k times n divided by n, which is equal to arctangent of mu k. And in this case, mu k, this one we will say this is equal to phi k. And this is also an angle of friction. But in this case, phi k is smaller than theta. So it slides downward. Because this one is right angle and this one is right angle. So if this phi k is smaller than theta, that resultant force is going this way. So the resultant summation F is going down the slope. Okay. Remember, when there is motion, that is F is equal to mu k times n, and if it is motion independent, that is F is equal to mu s times n. So it comes to the idea of angle of friction. It is another way of writing mu s and mu k, but it has uses here and it has uses in our next topic.